Hello learner, I am Dr. Purnima Tiwari, Assistant Professor of Mathematics, the Bhopal School of Social Sciences. In this video, I will explain about divergence of a vector function. Let us start with its definition. If a vector function of variables x, y, z is given and it is continuously differentiable function, its divergence is a scalar quantity and this is denoted by divergence of f and it is defined by nebula dot f. So, whenever we have to calculate divergence of any vector f, we will use this as a formula, and after substituting the value of this operator del and vector f, we can calculate this dot product or get the value of divergence. We know that the value of this vector operator nebula is I cap del by del x plus j cap del by del y plus k cap del by del z. And to this vector function f, we can write in its component form. So, this vector f can be written as fx I cap plus fy j cap plus fz k cap. This fx, fy, fz are components along x axis, y axis and z axis respectively. So, now we can substitute value of nebula or vector f. We get I cap del by del x plus j cap del by del y plus k cap del by del z. Dot product with fx I cap plus fy j cap plus fz k cap. Now, we have to apply formula to calculate dot product. The component of I will multiply with the component of I, that is we will get del by del x of fx. Similarly, component of j cap will multiply with another component, we will get del by del y of fy plus next we will get del by del z of fz. So, this can deal like a formula for divergence of vector f. Next we will find divergence of a constant function. Suppose we have given a vector function a, which is a1 I cap plus a2 j cap plus a3 k cap, and this is a constant vector. That means a1 is a constant. So, when we find derivative of a1 partially with respect to x, we will get 0. Likewise, a2 is also constant. So, whenever we differentiate it partially with respect to y, we will get 0. And the last one, a3 is also constant. When we differentiate it partially with respect to z, we will get 0. That means, this is a constant function. So, its component along x, y, z axis will be constant and their derivatives will be 0. That means, if we calculate divergence of this vector a, which is given by del a1 by del x plus del a2 by del y plus del a3 by del z. Since all these three values are 0, so this divergence would be 0. That means divergence of a constant vector is always 0. Next we will study a property related to sum of divergence. Suppose two functions are given to us, vector functions, that is f1 and f2. If we have to calculate divergence of their sum, that is, if we have to calculate divergence of f1 plus f2, this would be equal to divergence of function f1 plus divergence of function f2. You can use it as property of divergence of a vector function. Next we will solve a question where we will find divergence of vector r. This r is position vector and it has a standard value x I cap plus y j cap plus z k cap, where x, y, z are the values along coordinate axis x, y and z. Now, when we have to calculate divergence of this vector r, our formula is nabla dot r. First, we will substitute the value of this vector operator nabla and the given vector r. We will get I cap del by del x plus j cap del by del y plus k cap del by del z. Dot product with the vector x I cap plus y j cap plus z k cap. Now, to further solve, we have to apply formula for dot product. So, just recall this formula. If vector A is A1 I cap plus A2 j cap plus A3 k cap and vector B is B1 I cap plus B2 j cap plus B3 k cap. Then their dot product A dot B is given by A1 B1 plus A2 B2 plus A3 B3. So, to get value of this dot product, we will apply this formula. So, after applying formula, we will get del by del x of x, partial differentiation with respect to y of y plus partial differentiation of z with respect to z. When we differentiate x with respect to x, we get 1. Likewise, when we differentiate y with respect to y, we get 1, and differentiation of z with respect to z is 1. That means, this value is 3. So, whenever we calculate divergence of this standard position vector r, this value is 3. That is our answer. Next, we will find divergence of this vector f, which is x square plus y square I cap plus 2xy j cap plus y square minus 2xy k cap. So, we will use the formula of divergence. Divergence of this vector f is nabla dot f. We substitute the value of this nabla operator I cap del by del x, j cap del by del y plus k cap del by del z. Dot product with the given vector f. So, it is x square minus y square I cap plus 2xy j cap plus y square minus 2xy k cap. Now, to take dot product, we will use the formula dot product of vector A with B is A1 B1 plus A2 B2 plus A3 B3. So, this is our A1, A2, A3, this is our B1, B2, B3. A1, A2, A3, B1, B2, B3. Now, when we apply formula, we will get del by del x of the function x square minus y square plus del by del y of the function 2xy plus del by del z of the function y square minus 2xy. Now, when we differentiate partially x square minus y square with respect to x, so this will deal like a constant and will differentiate only x square, so we will get 2x. Now, when we differentiate this term 2xy partially with respect to y, so we will do the differentiation for y, that will be 1 and this 2x will as it is. Now, this whole term y square minus 2xy is independent from z. So, whenever we differentiate it partially with respect to z, we will get 0. So, in this case, divergence of this given vector f is 4x. That is our answer. Next, we will calculate divergence of this vector f x y square I cap 2x square y z j cap minus 3 y z square k cap at the given points 1 minus 1 and 1. That is, first we will calculate value of the divergence and then we will substitute value at this point. So, for calculating divergence of this vector, we will apply the formula nebula dot f. We will substitute the values of nebula as well as vector f. So, we will get I cap del by del x plus j cap del by del y plus k cap del by del z. This is the value of nebula operator. And now we will write vector f x y square I cap plus 2 x square y z j cap minus 3 y z square k cap. When we take dot product, we will apply the formula to get dot product, which is A1 B1 plus A2 B2 plus A3 B3. So, here our A1 is del by del x and B1 is x y square plus value of A2 is del by del y and B2 is this term 2x square y z plus the third term would be del by del z operating on minus 3y z square. Now, we have to do partial differentiation. When we differentiate this term x y square partially with respect to x, we will differentiate x, that will give us 1 and this y square as it is plus. Now, when we differentiate this term 2x square y z partially with respect to y, we will do differentiation for y, that will be 1 and the term 2x square z will as it is. This plus minus is minus. Now, the term 3y will be as it is and we will do partial differentiation of z square with respect to z. So, that will give us twice of z. So, on further simplifying, this term would be y square plus 2x square z minus 6y z. Now, we have to find value of divergence at this point. That means, in this value we will substitute x equal to 1, y equal to -1 and z is equal to 1 to get the desired value. So, after substituting y square, that is -1 square, plus 2 as it is, x square means 1 square, z multiplied with 1 minus 6, y is -1 and z is 1. Now, when we simplify it, we will get 1 plus 2 and this minus is plus 6. That means, in this case the value of divergence of vector f at the given point 1 minus 1 1 is 9. That is our answer. You can solve some more examples for divergence of a vector function for better understanding of this topic. Thank you so much.